Okay, so in the last video, we wrote a series of functions that works well if our initial input is 4. It will add up the first 4 numbers. Doesn't work so great if we're trying to add up, if we give it an input of 3, because it'll keep subtracting numbers too long. Actually, 3 might work because we'll get a 0 here, right? And return a 0, but 2 wouldn't work, or 1 wouldn't work very well as inputs, and neither would 27 work very well as inputs, because it's only going to input, then it would be input, it would add 27, 26, 25, 24, instead of going all the way back to 1. So the way to do this right is to do a recursive function. So let's do that. So I'm going to save this as recursion4, and I'm going to get rid of these guys. I don't want to pass on to this anymore. Oh, I want to keep in mind, though, I need a pass the buck stop situation here, right? Some way to return, just return the n. So when do I want to return the n? Well, I want to return the n when n equals 1, right? And actually, I could make this even a little more flexible if I said, if I let it go all the way to 0, right? Because then if let's say if I input 0, this will still be 10, but then I could say add number 0 if I wanted to, and it would give me the right answer. Okay, so it'll start from whatever the input number is and add up all the way down to 0. And then let's make this recursive. So go back here, and now let's debug this guy again and make sure. Well, I'm going to run it first just to show you that it gives us the right thing. It gives us a 10 here, but let's and you can also give it a 5, and it'll give you the right thing, right? 15, that's what it should be. So, but let's just run this in the debugger so we see how it's working. So basically, the idea is we're saying if I want to add numbers, if I want to do it for 4, I just add 4. I have this guy do all the other numbers. I have this guy add together 3 plus 2 plus 1 plus 0, and then I just add 4 to it, and that'll give me that. Okay, and you just keep kind of doing that each time. So let's look at how that works. So I'm going to say debug, and yeah, let's just step through. So we're going to define each of the functions. Oh, we only have one function to define. Nice. And then we're going to, now we have to resolve this, okay? So before we can print add numbers 4, we have to calculate what that is, right? So we're going to have to call add numbers before we can print anything. So let's, oh, I said step over instead of step into. Hold on a second. So step over. I want to step in to add numbers. Okay, 4 evaluates to a 4. So then what does add numbers of 4 equal? Well, let's see. So right now let me make this box a little bigger if I can. Will it let me? Yeah. So n is 4 now, right? Because that's what we called it. We said give me add numbers 4. So let's step into that guy. And we're saying, okay, if n equals 0, return n. So we got to check to see if n is equal to 0. So we need to resolve what n is. N is 4. So is 4 equal to 0? 0 is equal to 0. Is 4 equal to 0? No, that's false. So since that's false, we're going to return all of this. Now we have to resolve the n, and we have to resolve add numbers n minus 1. So let's see. What is that? So n is 4, right? That's what we passed in. And we're going to pass n minus 1 to add numbers. So what's n minus 1? Well, n is 4, 4 minus, and 1 is 1. 4 minus 1 gives us 3. So now we've got to call add numbers with the input of 3. So we're calling the same function again, but this guy didn't go away, right? This guy is waiting to hear back from add numbers 3. So he's still there waiting. But now we need to check. Now we have, so we basically have another copy of the add numbers function, but n, in this case, n is equal to 3. So let's do our check is, oh man, I gotta, so let's see, let's try to resolve this if block here. So if n equals 0, so n is 3, 0 is 0, so is 3 equal to 0? That's false. So let's go down here. So now we're going to return this. So now this guy's saying, all right, I need to give you all these, the numbers 3 through 0 added together, because I gave a 3. But all I'm going to do is I'm going to, since I'm working on 3, I'm just going to add 3 to whatever the sum of all the other numbers are. I'm going to pass on this work. I'm going to pass on the hard bit to the next guy, and he can add together 2 and all the numbers less than 2. Okay, so let's see how that works. So we're going to step over. Okay, so n is going to resolve to 3, right? N minus 1 should resolve to 2. So let's see how that goes. N is 3. N minus 1, that's 3 minus 1. 3 minus 1 is 2. So now we got to call add numbers with a value of 2. And whoa, now we're here, where n is 2. Again, this function didn't go away. It's waiting for add numbers 2 to come back. And this function didn't go away. It's waiting for add numbers 3 to come back, okay? So all these guys are still, they're just kind of, these guys up here are just kind of sleeping, just kind of waiting for their subordinate guys to come back and wake them up. So let's see. So now let's step over. So now n is 2. So n resolves to 2. 0 is 0. Does 2 equal 0? No. That's false. So let's go down here. And now we're going to add 2 plus add numbers to 2 minus 1. Let's resolve those guys. So now n is 2. Yeah. And now we're going to add numbers. We have to resolve what's n minus 1. Well, n is 2. 1 is 1. 2 minus 1 is 1. So now we've got to call add numbers 1. Okay, so now we're saying is n equal to 0? Nope, it's not equal to 0. So let's go down one more step. Oh, so this is going to, yeah, n1 is, and 0 is 0. This is going to be false again. So now we're going to say 1 plus whatever this guy is, which seems like a silly step at this point, but again, this will allow us to say add number 0 and get the right answer. So add numbers, n is 1, 1 minus 1 is 0, so let's call add number 0. Okay, so now we're getting to the buck stops here part. N equals 0. The value of n is 0 here. So now let's see, n resolves to 0. 0 is 0. Is 0 equal to 0? Yes. So we can just return n. What's n? N is 0. So we can just return 0. Now, notice that add number 0 box went away because that function is all finished. It returns a 0. So now we're working with the version of add numbers n where n is equal to 1. Okay? So we're going to return 1 plus 0. So how does that go? 1 plus 0 is 1, so we're going to return a 1, and this box is going to disappear in the next step, add numbers 1, because we're returning, and now it's gone. So now we're here, where n is equal to 2. So this is our unwinding part now, right? It's after the value has been calculated that we're kind of unwinding now. So now the previous add numbers passed back, returned a value of 1, right? Because 1 plus 0 is 1. So now we can add our 2 to that 1. So let's do that. 2 plus 1 is 3. And now we can go back to our add numbers 3. This is our version of add numbers where the value of n was 3. So now we can say 3 plus 3. So we've already taken care of these guys. This added up to 3. We returned the 3, and now we can add this guy. So here's our 3 plus 3. And we step into that. And then we return a 6. Okay, so we're going to return that. Now we've popped back to here. So now we've taken care of all of these guys. We added up 3 plus 2 plus 1 plus 0. We got a 6. Now we just need to take care of, now n, we have a value, n has a value of 4. We just need to take care of 4 plus 6. 4 plus 6 is 10. Boom, we returned a 10. So now our print function has its value that was returned from our top level add numbers here. And so now we can, I'm just going to do a step over. Now we can print out our 10. And there it is. All right, so that's the recursive version of add numbers.